Welcome! Today we'll explore how LittleHorse enables you to easily coordinate business transactions across multiple microservices. Without LittleHorse, engineering teams are often forced to use the Transactional Outbox pattern, which is highly complex and time-consuming to implement. Typically, implementing the Transactional Outbox pattern requires extensive setup, an additional database table, dual writes within a transaction, and a complex change data capture CDC system like Debezium and Kafka Connect. Not to mention the stream processing to make CDC data usable by a microservice. It's a necessary headache to ensure data consistency without 2PC, but it's a complex one. LittleHorse takes all of this complexity away, providing all the benefits of the Transactional Outbox pattern without the usual hassle. We've built a short demonstration to help you understand how LittleHorse makes this happen. A big shout out to Mijaíl Rondón from our team for building this cool demo for us. We begin by setting up our demo environment with Docker. This includes spinning up several microservices, each playing a critical role in our transactional system. These services interact seamlessly thanks to the magic behind LittleHorse. While our Docker images spin up, let's look at our workflow. When a payment transaction is initiated, the process payment service takes over, followed by ship item, and if necessary, issue refund. It's a streamlined process, but behind the scenes, there's a lot going on. Now, if you look at this architectural diagram, each service like payments and warehouse interacts with its own API and database. But instead of writing to an Outbox table and managing CDC, this demonstration relies upon LittleHorse workflow primitives in order to guarantee that your transaction happens properly. LittleHorse guarantees that the ship item task will be called after the process payment task completes successfully, without the need for any complex Outbox table and CDC infrastructure. Now watch as we make a transaction. First of all, we'll use the commands available in our GitHub repo. Once we've set up our code, let's top up our gift card with a balance of $138.57. All of the gift card says gift 130, but it'll be good for our demo. Next, let's paste the other curl command to load up some cookies. We'll be loading 30 cookies. So, we see there are 30 cookies available. We're going to purchase a lot. So let's apply our gift card code gift130 and set a payment transaction in motion. See the immediate response of the front end? The transaction status is visible. Our order was dispatched and the payment went through successfully. And now no cookies remain in stock. Attempting to order a single cookie now displays a message that although the payment was accepted due to sufficient gift card balance, a refund was issued promptly as the cookies are out of stock. Now, for the final scenario, we restock 2 cookies. As our gift card balance falls short of the order amount, we'll receive a notification of insufficient funds. Let's test it. Okay, so we had some existing balance. So we could buy 1 cookie, but once we try to buy another cookie, we can see it fails. Note, in LittleHorse, we distinguish between technical errors and business exceptions to maintain transactional integrity and a smooth user experience. Technical errors like network failures or server crashes are system-level issues that are often unpredictable and are not related to business logic. LittleHorse handles these gracefully to keep the system stable and available. Business exceptions such as credit card declines or items being out of stock are part of the expected flow of any transactional system. These are handled within the happy path of customer interactions, ensuring that users receive proper feedback and the system remains consistent and reliable. This approach allows LittleHorse to provide clear, maintainable operations, keeping system robustness and user clarity in focus. That concludes our demo. Now, let's dive into the code for a richer understanding. The OutboxWorkflow.java class defines the LittleHorse workflow specification, also known as a workflow spec, defining steps for payment processing and item shipping. It elegantly manages transactions and ensures a smooth user experience by handling out-of-stock exceptions with a refund process. The PaymentsTask.java class processes payments and demonstrates the system's robustness. It handles business constraints like insufficient balance by notifying the system of the failure, ensuring the system's transactions are reliable and consistent. Task.java is the foundation for all tasks within our system, encapsulating shared functionalities such as account debiting and transaction event publishing. This promotes code reuse and clarity in transaction management. The warehouse.task.java class extends the task class to manage item shipments. It ensures the correct debiting of stock quantities and implements exception handling for scenarios where stock is insufficient, safeguarding against incomplete transactions. Under the hood, LittleHorse performs the heavy lifting to make the Transactional Outbox pattern accessible. No extra tables, no dual writes, no direct CDC management, and no need for ancillary stream processing. In conclusion, LittleHorse presents a potent method to harness the transactional outbox pattern without its customary complexity. For developers and enterprises alike, this translates to more time devoted to value creation rather than infrastructure management. Thank you for joining us. If you're looking to implement reliable microservices transactions with ease, look no further. Until next time, keep it simple and efficient.